Hello friends, in this question we are asked to find the energy stored in capacitor C2, okay, and the initial voltage is given as 10 volt across capacitor C1 and the switch is closed at t equal to 0, okay. So here the capacitors C2, C3 and C4 are not charged, okay, before the switch is closed, and C1 is at 10 volts, okay. So how to proceed for this question? So let us see intuitively what will happen. So when switch is closed, okay, this capacitor starts discharging through this resistor across these capacitance, and what will happen is this capacitor voltage will go down and this capacitor voltages will go up, okay, and a point will come where these two voltages, okay, the voltage across this capacitor and this combined capacitance, okay, this equivalent capacitance will become equal such that no current flows across this resistor, okay. That is the steady state here, okay. So how to proceed for this question? So we will use law of conservation of charge, okay, because the charge which was in the system before the switch was closed will be same as the charge which will be there during the steady state, okay. So let us proceed for the solution of this question. So here the formula that we will be using is capacitance is equal to Q by V, where Q is the charge and V is the voltage across the capacitance, okay, or Q is equal to CV, okay. So these two are the important formulas, okay. So let us say that Q is the charge across which was there in the capacitance C1 before switch is turned on, okay. Now that this charge was Q1 before the switch is turned on, okay, was Q before the switch was turned on, okay. So what will happen at steady state? At steady state, I said like no current is going to flow in the circuit. That will happen when this voltage VA and VB, okay, will become same, okay. So VA will be equal to VB and no current is going to flow, okay. Now one more thing we will assume here, that the capacitance across B and O, okay, is C equivalent, okay. So that is C equivalent, okay. Now how to calculate the C equivalent? It's very simple. This C2 is in series with two capacitances which are in parallel, so parallel capacitances add up, okay. So this is addition of these parallel capacitances C3 and C4, okay, and it is in series with C2. So this will be the net capacitance and we get net capacitance as 4 farad, okay. So once we get 4 farad as our net capacitances, what we'll do is we'll close the switch and we'll see the condition when VA equals to VB, okay. Let us say that VA becomes VB in steady state. During that time Q1 will be the charge stored in C1 and Q2 will be the charge stored in C equivalent, okay, C equivalent. Now what will happen is these charges Q1 plus Q2, okay, should be equal to the initial charge which was Q, okay, because the charge can neither be created nor be destroyed, okay. So this Q1 plus Q2 will be Q, okay. So this is the equation now. So now let us calculate our Q. Q is simple to calculate, okay. Before the switch was turned on, Q is equal to C into V, okay, or this is C1 into V, okay, because only capacitor C1 had charge, okay. So that is capacitance 1 into voltage was 10 volts, so it is 10 coulomb. Now when the steady state is reached, Q1 plus Q2 should again be 10 coulombs, okay. So now we can substitute the value of Q1 and Q2, okay. So let us do that. So now when we substitute the value of Q1 and Q2, okay, Q1 is equal to Q is equal to CV, so Q1 is equal to C1 into VA, okay, the voltage across this capacitance, okay, VA, and uh, C equivalent into VB will be your charge across C equivalent, okay. So this should be equal to 10, okay. Now you can see that VA should be equal to VB at steady state, okay. That's why I have substituted VA with VB here, and from here I get VB is equal to 10 by 5 is equal to 2 volts. So now I have my VB here. Now once I get my VB, what can I do? Well, I can find my voltage drop across this capacitance C2, okay. So let us do that. Now the capacitance across the voltage across C2, let us say that is V2. Okay, so this capacitance is 8 farad. Okay, and this voltage now at steady state is 2 volt, as we have calculated already. Okay, this voltage VA is also 2 volt, and what will happen is now our drop V2 will be 2 into 8. Okay, this 8 over 8 plus 8, which will be 1 volt. Now we have got our drop across the capacitance C2. Okay, so once we have calculated our drop across C2, what we need to find? We need to find the energy stored. The energy stored will be half CV square. Okay, this is the energy stored. So here in this case it will be half into C2 into V2 whole squared. Okay, so that is equal to half into 8. 8 is the capacitance value into 1. 1 volt is the voltage across the capacitor. So that will give me 4 joules. So the answer to this question is 4 joules. So this is how you can solve this question. So thanks for watching.